Greetings to you and welcome specially to Bengineer Construction Lecture Hub. Always a platform where you get vital updates as regards to construction. All right, so today we are going to look at basically the cutting length of lateral tie. Now, you know, in our columns, we have lateral ties or transverse bars that helps to hold the main bar in place. So for us to calculate the cutting length that will be able to produce this lateral tie, okay, for a square column of 300 by 300 millimeters, we are considering the concrete cover as 40 mm, okay, then diameter of ties as 8 mm, then one hook is equal to 9D, then 90-degree bend is equal to 2D, then 135-degree bend is equal to 3D. Now I want you to understand that this is practically how you are expected to calculate your cutting length. All right, depending on the parameters you have here, you can now follow this procedure to calculate the cutting length. All right, and this will aid the bar bender to be able to cut correctly and do the bendings correctly. All right, so let's go. So if you look at this diagram, we have the length, the breadth is a square column, so 300 by 300. We have B here unknown, we have A here unknown. So A is equal to the overall length of the column with 300. So we minus the concrete cover for both ends, but for both sides. So 40 minus 40, that will give us 220 mm. So for the B side as well, since they are the same, so we have 300 minus 40, which is 220 millimeters. Then we calculate for the hook length for two hooks. Now look at the two hooks here. We have one, we have two. Okay, so that's the two hooks, and we know that one hook here is equal to 9D. So we have 9D plus 9D for the two hooks will give us 18D. Then we calculate for the bend length for three bends at 90 degrees and two bends at 135 degrees. So let me explain this. Now, if you look at this diagram now, we have the angle here is 90. Okay, the angle the stirrup makes here is 90, so we have 1. Then at this point, it also makes 90 degrees. We have 2. At this point, it also makes 90. We have 3. So that is how we have 3 bends at 90 degrees. Then if you look at this one here, the bend here is 135 degrees. So we have two 135 degrees for the hooks. Okay, the two sides makes 135 degrees. So we have 2, 1 and 2. So that is how we have two bends at 135 degrees. So when you compute this, we have 3 bends times 2D for 90 degrees. 90 degrees is 2D, 135 degrees is 3D. So for 90 degrees, we have 2D. So you multiply 3 by 2D, then plus 2 times 3D. We have 135 degrees gives us 3D. So this is the standard parameters in computing the cutting length. So when you work this out, we have 12D. All right, so we have total cutting length. All right, will give us parameter of square. Okay, the parameter of square is the 4 sides of this square rather. So then we have parameter of square plus total hook length minus bend length. So when you substitute, we have 4 times 220. Now this 4 has to do with the 4 sides. Okay, 1, 2, 3, 4. So that is why we have 4 here times this 220. So plus 18D minus 12D. So when you substitute, you have 880 plus 18 times 8, which is the D here is the diameter. Okay, diameter of tie 8 mm. That is what we adopt. So we have 18 times 8 minus 12 times 8. So that will give us 880 plus 144 minus 96. So it will give us 928 millimeters. So this is now the cutting length, okay, that the bar bender is expected to cut from the standard length of the full standard length of 8 mm diameter bar to be able to produce this shape of tie for this column. All right, so this is a well-defined approach, in calculating the cutting length of a lateral tie. All right, so do well to stick to the Engineer Construction Lecture Hub. Follow this page if this is the first time you're coming across this video for more valuable updates as regards to construction. Thank you very much, and do have a splendid day. Thank you.